Now we will discuss the formation of anion. We know what are anion. Anion are negative charged particles or negative charged species. Anion are formed when an atom gain one or more electrons in a chemical reaction. We will understand formation of anion by taking the example of formation of oxide ion. Oxygen gains 2 electrons in a chemical reaction and converted into oxide ion. Oxygen is a member of group 6C of the periodic table. It means oxygen has 6 electrons in its valence shell. First of all, we will write the electronic configuration for oxygen. Oxygen, atomic number 8. If we write the electronic configuration for oxygen, its electronic configuration will be 1s2, 2s2, 2p, 4. This is the electronic configuration for oxygen. We know 1s, it is the subshell of K shell, and 2s and 2p are the subshell of L shell. It means in the valence shell of oxygen there are 6 electrons. 6 electrons are present in L shell. Now to get the stability, electronic configuration of oxygen must be similar with the noble gases. It means oxygen must have 8 electrons in its valence shell to get the stability, to get the similar configuration just like noble gases like neon, argon, etc. So what will oxygen do? It will gain 2 electrons in a chemical reaction. When oxygen gains 2 electrons in a chemical reaction, after the gain of 2 electrons, its configuration will be 1s2, 2s2, 2p6. Now we know 1s is the subshell of K shell, 2s and 2p, these are the subshell of L shell. Now here we can notice in the L shell, which is the valence shell of oxygen, there are 8 electrons. Now electronic configuration of oxygen is similar with the noble gases. Simply we can write this reaction as oxygen when gains 2 electrons in a chemical reaction. After the gain of 2 electrons, oxygen changes to oxide ion. It has -2 charge. Since oxygen gained 2 electrons in a chemical reaction, that's why it will attain -2 charge. We can also represent formation of oxide ion with the help of electron dot structure. Let's see what is the electron dot structure for oxygen. We make 2 electrons in the first shell of oxygen, that is in K shell. 1, 2. These are the 2 electrons which are present in the first shell of oxygen. Now we write the 4 electrons in the L shell, that is the valence shell of oxygen. 1, 2, 3 and 4. So in the L shell of oxygen there are 4 electrons. So oxygen has 4 electrons in its valence shell in L shell. In order to complete its octet in the valence shell, oxygen gains 2 electrons in a chemical reaction. So after the gain of electrons, oxygen is converted into oxide ion. Now we will write the electron dot structure for oxide ions. We will write 2 electrons in the K shell for oxygen, that is 1, 2. Then 4 electrons, we will write the 8 electrons after the gain of 2 electrons in the valence shell. Octet is completed. So we write 8 electrons in the valence shell. 1, 2, 3, 4. We can show the formation of oxide ion with the help of electron dot structure for oxygen. So we write 2 electrons in the first shell, that is in the K shell of oxygen, that is 1, 2. These are the 2 electrons which are present in the K shell. Now in the L shell there are 4 electrons, so we make 4 electrons in L shell. 1, 2, 3, 4, 5, 6. These are the 2 electrons which are gained by oxygen in a chemical reaction to form oxide ion. So after the gain of 2 electrons, the octet of oxygen is completed in the valence shell, that is 1, 2, 3, 4, 5, 6, 7, 8. Now the octet of oxygen is completed and oxygen is converted into oxidine. I hope formation of oxidine is clear to you. Now we will study the formation of fluoridine. We know fluorine is a member of group 7th of the periodic table, that is halogens. Atomic number of fluorine is 9. In the valence shell of fluorine there are 7 electrons. Fluorine needs just 1 electron to complete its octet to get the electronic configuration similar with the noble gas. So usually fluorine gains 1 electron in a chemical reaction to get the stability and convert it into fluoridine. Now we will understand the formation of fluoridine by writing the electronic configuration for fluorine. We write the electronic configuration for fluorine. Fluorine, atomic number 9. Fluorine, its atomic number is 9. If we write its electronic configuration, it would be 1s2, 2s2, 2p5. We know 1s is a subshell of K shell and 2s and 2p, these are the subshell of L shell. So L is the valence shell of fluorine. In the L shell there are 7 electrons. In order to complete the octet, fluorine gains 1 electron in a chemical reaction. After the gain of 1 electron, electronic configuration of fluorine would be 1s2, 2s2, 2p6. That is, in the K shell it has 2 electrons and in the L shell it has 8 electrons. Now its octet is completed. Now its electronic configuration get matched with the nearest noble gas and it becomes stable. We can also understand the formation of fluoridine with the help of electron dot structure. Electron dot structure for fluorine is, now we will see the formation of fluoridine. We will see the electron dot structure for the formation of fluoridine. First of all, we will write the electron dot structure for fluorine atom. Fluorine has 2 electrons in its K shell. So we write 2 electrons in the first shell, that is K shell, 1, 2. In the second shell, which is the L shell, there are 7 electrons. So we write 7 electrons in L shell, 1, 2, 3, 4, 5, 6, 7. So in this way there are 7 electrons in the valence shell of fluorine. In a chemical reaction, when fluorine gain 1 electron, after the gain of 1 electron, fluorine changes to fluoridine. Fluoridine has 8 electrons in the valence shell. Now its electronic configuration get matched with the noble gas and it becomes stable. We will make the electron dot structure for fluoridine. We will write 2 electrons in the first shell, which is the K shell. We will write 2 electrons in the K shell of fluoridine, 1, 2. So in this way there are 2 electrons. In the L shell, which is the valence shell of fluoridine, there are 8 electrons. After the gain of 1 electron, 1, 2, 3, 4, 5, 6, 7, 8. So this is the electron which is gained by fluorine atom. After the gain of this electron, fluorine is converted into fluoridine. I hope electron dot structure for the formation of fluoridine is clear to you.